Hello students, today we're going to continue with 10.3. We are looking at, oops, I just moved it. We are looking at 10.3 gene pools and speciation. And just quickly, in the last video we talked about the mechanisms of change. So what are those processes that drive change, meaning drive allele frequency change in a gene pool? So we said that there were 5, right? Mutation, gene flow, sexual reproduction, genetic drift, and natural selection. So today we're going to be looking at genetic drift and how that is a mechanism of change that is going to drive a change in the allele frequency. So let's get started. So the skill for this section is to be able to do a comparison of allele frequencies, of geographically isolated populations. So let's start by understanding genetic drift and what drives genetic drift. So one thing to keep in mind when looking at genetic drift, genetic drift is going to occur faster and is going to be more significant in smaller populations, right? That's because these chance events are going to have a bigger impact on the gene pool. If it's a large population, it's going to be less affected by different chance events, and the population is going to remain more stable when it comes to their allele frequencies. So they're going to have low genetic drift. So when we think of genetic drift, we think of any allele frequency change which leads to a change in the gene pool as a result of some chance or random event. Okay? So there are 2 types of mechanisms within genetic drift. The first one that we're going to look at is population bottleneck effects, and then we're going to look at the founder effect. Okay, so let's look at the bottleneck effect right here. So population bottlenecks occur when there is an event, some chance event, that reduces the population size by an order of magnitude of approximately greater than 50%. So these bottleneck effects may result from natural occurrences like fires, floods, hurricanes, some type of catastrophic event, but it can also be human-induced, and we're seeing a lot more of this in the example of overhunting. So what happens in this bottleneck effect? In this bottleneck effect, the surviving population, which would be this right here, has less genetic variability than what it used to have before. So it will be subject to a higher level of genetic drift. So as these surviving members begin to repopulate, the newly developing gene pool will be divergent to the original, which is this. So the example that they give you here are the northern elephant seals that have reduced genetic diversity compared to the southern seals due to overhunting. So overhunting is that human-induced chance event. So here we look at the gene pool comparison of a population that was the original population, and notice that the allele distribution here is equal. So then some type of bottleneck effect happens, and that means that not all the alleles can make it, right? So only these alleles come out after this chance event. So then the new population has a different proportion here of alleles. Now, of course, that's a mechanism of change because you are changing the allele frequency, right? You're changing the gene pool. Therefore, it is an evolutionary change. All right, and the founder effect is also an example of genetic drift, and this occurs when a small group like this breaks away from the mother population or the larger population, and it colonizes a new territory, or it just moves away. So this population subset doesn't have the same degree of diversity as this larger population, so it's subject to more genetic drift. So as this new population starts reproducing and it starts increasing in size, the gene pool that you see here and the allele variations that you see here are not going to be representative of that original mother population. So this new population has shifted, right, in its allele proportions, and it has shifted in its gene pool. So now there's some form of change here. Now, sometimes these changes don't necessarily mean that is going to be a change in species per se. The example that they give you here of a founder effect is how certain Amish communities have a higher incidence of polydactyl because of intermarriage within the community. So if we think of the Amish population here as this new population that's broken away from the greater population, right? It doesn't mean necessarily that they become a new species, right? But they have a different allele combination, so they have a different ratio of alleles, so certain traits or certain characteristics are going to be of higher incidence than others, okay? And we see it with populations that tend to be closed off from the rest of the world. The information here below, it's interesting for you to look at. It's not required for you to be able to get any significant information from this Alfred database. But if you want to look at allele frequencies between populations, in populations, let's say in North America compared to populations in Europe or Africa, this database compares all of the allele frequencies of all the different genes of Homo sapiens. So here they give you a couple of examples that you can look at using the Alfred database. And they give you 3 examples. So they give you the human melanin production gene, they give you the ABO blood type gene, and they give you the lactase gene for making lactose. Lactase for tolerating lactose, sorry. And in this particular examples, they just show you the allele frequency and how they differ in different parts of the world. So the graph here below is just a comparison of a particular mutation in this gene, the SEL45A2 gene, and how you have different allele frequencies in Northern Europe in comparison to the rest of the world. And that's because some mutation happened here in this allele, in this gene. So for example here, you have some variants, right? So in the blue ones, you have leucine at position 374 of that particular gene. And in this population, you have a mutation, and you have phenylalanine at position 374 of that particular gene. So that means that the allele frequency is going to be different in this population, and that's going to have some phenotypic effect in that particular type of melanin production for that one particular gene. Okay, so that's it for today.